Okay, so now we're in 1.4, and notice in the title here we have rate of change again. So we have polynomial functions and rates of change. So what we've been working with up until now, they've been polynomials. They've just been specific types, namely linear, which are lines, and quadratics, which are parabolas. Anything after that doesn't get a special name, but it's part of the family of polynomial. So a polynomial is defined as a monomial or the sum of monomials. So like looking ahead, here's a polynomial, which is a sum, pluses and minuses of individual terms. That's basically what it's saying. And we always want to have our polynomials in standard form, and that is where the exponents are in descending order. For example, this one's in standard form. 5x to the 4, x to the second, and then no x. Whenever you don't see a variable on a number, it means it's a constant. That's what we call it, constant. But if you look at this polynomial, it's not in standard form because the exponents are all out of order, okay? And we're going to break down this crazy-looking setup of a polynomial into some individual parts. It looks really crazy. Don't stress about it. It's nothing to be stressed about. But some words, some vocab we need to know. Big one is degree. The polynomial has a degree of n. That's your biggest exponent. Whatever that number is, the biggest power that you have is called the degree. Really, really widely used term. In this class, I will talk about the degree of a polynomial a lot. So you just know from now on, degree is the biggest power, okay? We have a leading term. That's the number and the letter and the exponent, that whole first term. That's called the leading term. And then the leading coefficient would be the number in front of the variable, that a sub n, okay? And we'll break all that down here in a second. Turning points are a point where the graph of a function changes direction from up to down or down to up. So it's like a roller coaster. Like when you're going up, you hit the top before you go plunging down. That's your, that's a turning point, like where you change from going up to down, or at the bottom from going down to up. Turning points. And the number of turning points a polynomial will have is its degree minus 1. Remember, n is the degree. Okay, so degree minus 1. So and then one more thing we're going to talk about is end behavior, but we'll get to that in, I think 1.5. We talk about end behavior a little bit more. But end behavior is just the arrows at the ends of your graph and the directions they go, right? So this little section right here, let's just bust a move through this pretty quickly because these are, I didn't even give you any homework problems like this. This is just reviewing all the terms I just said. So looking at this f of x polynomial here, the leading coefficient is the number in front of the first term. So that would be -5. This would be a degree 4, and your turning point is always n minus 1, which is 4 minus 1. So this graph would have 3 places that it changes direction, okay? So you just subtract 1 from your degree. If you look at g of x is not in standard form, right? It's all out of order. The leading coefficient would be 2, so sorry. What would the degree be? Help me. 5, right? Even though this one isn't first, it's still the leading term. It's just out of order. So how many turning points? Oh, sorry. 4. 4 turning points. Our degree minus 1. Turning points is the maximum number of turning points a polynomial can have is n minus 1, degree minus 1. So what you're going to see, if I just use this graph, which I'm not using this part of the notes, how many turning points does this graph have? It has 3, right? There's a turning point, there's a turning point, there's a turning point. So this must be a degree 4, because you always have 1 fewer turning point than the degree. Okay? It's just a way to identify what the degree is, or vice versa. You'll see it on the next page. We'll talk about it again. All right, and this last function here, h of x, is in factored form, okay? It's not written out in standard form. It's got parentheses in it. That's considered factored form. We could make it look like these two by like foiling this all out, distributing, and be a lot of work, but you don't have to. All we care about is the first term. So what I can do is take the first term of each of my parentheses, each of my factors, so x, and multiply them together, times x squared times 10x, and that will get me my leading term. So it would be 10x to the what power, guys? 4. Add all your x's. We have 1, 2, 3, 4. Remember, those x's here and here have a 1 there, right? We're just adding all of our x's together. 1 plus 2 plus 1 is 4. So our leading coefficient would be 10. Our degree would be 4. How many turning points would this graph have? Yeah, just subtract them. Okay? Now, let's take turning points and focus on those on the next page. The next page, please. So turning points, we don't usually call them turning points. They're called minimums and maximums. And there's two types. There's locals and globals. So let's just talk about locals first. So this word, local, max, let's just say max and min. The umbrella term for mins and maxes is extrema, okay? So just stay with me for a second. Local, also you can use the word relative. These two words are interchangeable. You can have a local or relative max, local and relative min. They are your turning points. Every turning point is a relative min or max. Maxes are at the top of the graph, mins are at the bottom, okay? So let's break this graph down a little bit. On the graph at the right, I'm going to shade the interval of increase in green. So I have colors. You may not. Don't stress about not having colors. Your notes are your business. I'm not going to grade you on your notes, but if you wanted to like change the word green and to like put X's on there or open circles along it or right next to it, this is your max or interval of increase. So remember this, and this is a review, by the way. An interval of increase or decrease is just the places on the graph that are going up or going down, left to right. So we have an interval of increase here and here, right? Those are the places my graph is increasing. Where we're decreasing would be falling from left to right, right? So we've talked about that many, many times. Let's state those intervals. Again, more review. Lots and lots of take a few steps forward, learn something new, but also bring back the old stuff. We do that a lot in this class. So remember what intervals mean. Intervals is the x-axis. What part of the x-axis is our graph increasing? So let's take this one first. As it goes down, it's going to the left, right? So that would be from negative infinity to what number? At what number would I put next when it stops going up anymore? Negative 1. Daniel, what do you think the mistake is that a lot of people put there instead of negative 1?
6.
Yeah. Because when we talk about increase or decrease, our eyes are going up or down, right? So we're thinking, oh, well, this is where it stops going up. Stops going up at 6. Well, at y equals 6, yes. But the word interval is what part of the x-axis does it stop going up anymore? And that's at negative 1. Okay, so remember, interval is x-axis. And then it starts again at 2 on the x-axis. Remember, we want the x coordinate. And then to the right forever would be infinity. Okay? Decrease would be from here to here. Grab the x values. That's negative 1 to 2. Okay? Now, those turning points we are now going to call extrema. So there's all these words, extrema and extremum. One is plural, one is singular. I don't know the difference because we don't really use that word a ton. We'll just call it a min and a max. Like this is a max because it's at the higher part of our graph. This would be a min. So think of the difference. Max is at the top, min is at the bottom. What makes them what we call local or relative, either word interchangeable, what makes them that is that, think about what the word local means, like close by or relative to what we're looking at. In this little space right here, we have a local max and a local min. But we call them local because they're not actually the highest or the lowest point, right? These arrows, we know what happens with these arrows. The graph keeps going up. So there's an infinite number of points that are higher than this point, right? That's arrow tells us that. There's an infinite number of points that are lower than this one. But locally, like in our viewing area, we can call them a max and a min, specifically local or relative. Here's how we write it. So again, either word is fine. Interchangeable, you'll see it both ways. You can do it both ways. We have a relative max right here. This is how we do it. So look. The relative max value is 6. That's how high it is. It happens at -1. It's a weird way of writing it, okay? We have a maximum value. How high did it go? Up to 6. Where did it happen on the x-axis? At -1. This one would be a relative min. The relative min value is -6. And you can write the word at, and you might see the at symbol at 2. So we have a relative or local max and a relative or local min. So what is the connection between these extremas, that's what they're called, and the intervals of increase or decrease? Well, if you notice, where we have a turning point, the graph changes directions at those places. So one thing we could say is the graph changes direction at the extrema. And I know I'm throwing a lot of words at you. One more time, extrema is just an umbrella term for min and max. It's just like being able to group them together, okay? So this is, Daniel, where I said we would talk about this one again. What is the least possible degree of this this polynomial? So if we have 2 turning points, right, 1, 2, this would be a degree what? 3, because we have 2 turning points. So if you're given the turning points, you would add 1 to get the degree. If you're given the degree, you subtract 1 to get the turning points, okay? You don't have to find the equation, but we would know that the biggest exponent of the polynomial that represents this graph would be a 3, okay? In this next one, we're going to circle the local extrema and draw a dot at each 0. What's a 0? What's a 0? X-axis, where the graph crosses the x-axis, also known as an x-intercept, okay? So turning points I'm going to circle. So there it turns. These are your extremas, mins and maxes. And then I've got x-intercepts here and here. So notice in this graph, we have a 0 that's also a turning point. That's okay. They can be both. Here's an extrema, here's an extrema, x-intercept, 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 right? We should be able to pull these things off of a graph. Turning point, turning point, turning point, extrema, x-intercept, x-intercept, and in the middle of that little circle. Right? So I'm hoping you can look at these and notice something. The connection between the location of your zeros and the extrema are this. Your extrema can occur at a 0, right? Or look at the other option, in between 2 zeros. It's almost, we're going to kind of learn this later, dead center in between 2 zeros. So extrema can occur at a 0 or in between 2 zeros. Now, when we talk about a min or a max, we've only been talking about the local one, or relative one. Ready? There could we have a point that's absolutely the highest or absolutely the lowest? And the answer is yes. So change this picture for me. Put arrows on the ends here. So let's pretend it had arrows on it. And I think you guys will agree with me that we have a turning point right here. Would you guys agree that's a turning point? So that must be an extrema, and it's a maximum, okay? Because it's at the top of the graph. Are there any points that are going to go higher than this point? No. We know that these arrows are end behavior. It's going to keep on going down. We can't assume anything but the fact that they're going to keep going down, not curve around and come back, okay? So what we have here is a max, but it's a different kind of max. It's called an absolute maximum. It has another name as well, global. Why do they have to give us so many options? I don't know. But let's kind of compare them. Global and local. Local is like nearby, so close to what I'm looking at. Global is the absolute, there's nothing, it's in the whole world. Think about global, okay? Locally is close by, global is the entire graph. So there's no higher point than this. And you can also use the word absolute. So this would be an absolute max value of, what is that, 3 at 1. But guess what? If you're an absolute, you're also a relative. Let me say it differently. If you are a turning point, you are a relative min or max. Are you also an absolute max? That's what we have to see. So this is actually a relative or local and an absolute or global. Lots of words here I'm saying, okay? Let me put it all together for you in the pictures on the next page, okay? This is what your first 4 homework problems are going to be like, right? Where we look at a graph, we identify relative and global. Again, local, absolute. Whatever term you want to use is fine. So let's first identify turning points. We know something's happening here and something's happening here. I like to go ahead and identify the ordered pairs, so I just have that out of the way. That would be 3, 1. This point would be 1, 5, right? Just naming the points. If you are a turning point, you are a local or relative min and max. So we have a relative max and we have a relative min, right? We have a max and a min. And my max is 5 at 1. And my min is 1 at 3. You might see this too, 5 at x equals 1. Either way, okay, I think that's how I did it in the key. But either one of these is fine. Are either of these also an absolute? Nope. Because we have arrows going in these opposite directions, we have points that are going to go higher and lower than these local or relative extremum. Okay? Let's look at another one. We have a turning point here, turning point here, turning point here. So we have something happening at 3 different points. Those ordered pairs. And this is optional. I like to have all my information organized. So when I go to answer my question, I'm not still trying to figure out what the points are. -1, -2. So if we labeled you, you get a label, you get a name of relative min or max. Okay? We can have more than one of relative things. Like we have 2 relative maxes, right? We have a relative max value of 8 at 2. We have a relative max of 0 at -3. What? Say it one more time. I still can't hear you. I'll come talk to you, I guess. Relative min of -2 at -1, right? We labeled all those points. 2 maxes and a min. So think about a max as where we change from increasing to decreasing, right? Increasing to decreasing. And a min, we're changing from decreasing to increasing. But are any of these points absolute mins or maxes? Yeah. This guy gets 2 titles. We have an absolute or global, either one. At 8 at 2, where x equals 2. This one, by the way, had no absolute, right? We talked about that. Right? But you can only have one absolute max or one absolute min. You could have an absolute max, you can have an absolute min, but you would never have multiple. Like this one is not an absolute, right? There's a point that's higher than this one. This one's not an absolute either because of these arrows, we go down forever. This one would be an absolute min and a relative min, right? Both. All right. So list all your points as either a min or a max, and then ask yourself, are any of them the highest or the lowest? That's when you give them the absolute. That's it. Good? Not bad, right? All right, 1, 2, 5, and 6. You're going to do the same directions as we just did, okay? So when you get to number 5 and 6, they have different directions. Ignore them. 1, 2, 5, and 6. This is easier. I wrote it another way. My handwriting is messy right there. So 1, 2, 5, 6. All same directions as 1 and 2. Just like we just did. And then 11 through 18. So that should be written down 11 through 18. Mm-hmm. Mm-hmm. Okay. I will put the key up. You guys should probably be able to finish in class. Everyone has so far today. Give me a sec, I will come help you. I can do it really quickly though. Let me upload the. I know a lot of you guys in the back like to do that, so let me upload it right now. I usually do it during my planning. my planning is fourth. I tried to do it during the fourth, but I forgot to record during the third, so I just waited to do everything. It would take me a minute.